Yes, dear viewers, welcome back to our SSAT program. So, this is last class in differentiation. So, we have discussed the differentiation of higher order derivative. So, what it means? Successive differentiation, or it can also be called as higher order differentiation. So, I already explained the meaning of it, again I will repeat it. You will have a function, if it is differentiable you can differentiate it. What you will get? If y is equal to f of x, if it is differentiated, what you will get? We will get dy by dx. For instance, we can call it as f dash ex. It is the first order derivative. It is first order derivative. If it is the differentiable, again you go for differentiation. We will get d square y by dx square. For instance, I will show f double dash x. It is second order derivative. Again, if you go for further differentiation, they are the higher order derivative. D cube y by dx cube, d to the power of 4 x y by dx to the power of 4. Finally, you can find nth order derivative, d to the power of n y divided by dx to the power of n. It is nth order derivative. The derivative other than dy by dx, they are all higher order derivatives, second order, third order, fourth order, and we are differentiating successively. The derivative is differentiated successively, that is called successive differentiation. In the last class we discussed few examples. Some more I want to take it here. You take an example, y is equal to log of sin x. Y is equal to log of sin x. Find d square y divided by dx square at x is equal to pi by 2, at x is equal to pi divided by 2, or at x is equal to 90 degree. So, what is function given? The function is y is equal to log of sin x. Y is equal to log of sin x. Differentiate this, we get what? Dy divided by dx. Dy by dx is equal to log of function. Log function is what? 1 divided by function into d by dx of function. This is 1 by sin x into differentiation of sin x is cos x. Hence, I will write cos by sin is cot x. dy by dx is equal to what? Dy by dx is equal to cot x. Again differentiate this, again differentiate with respect to x. We get d square y divided by dx square, that is equal to differentiation of cot is what? Minus cosecant square x. Differentiation of cot x is what? It is minus cosecant square x. But what is our question? We have to find d square y by dx square at x is equal to pi by 2, at x is equal to pi by 2. We have d square y by dx square is equal to minus cosecant square of pi by 2, minus cosecant pi by 2, cosecant 90, sin 90 is 1, cosecant 90 is also 1, hence it is 1 square. Do not take it as whole square, it is minus 1 only. D square y by dx square is equal to what? Minus 1 is answer. Next question. y is equal to e to the power of 2x minus e to the power of 3x divided by 5. Find d square y divided by dx square at x is equal to 0. This is examination question. Y is equal to e to the power of x minus 2x minus e to the power of 3x divided by 5. We have to find d square y by dx square. Take y given function is equal to what? E to the power of 3x minus e to the power of 2x minus e to the power of 3x divided by 5. Differentiate this. Differentiation of this is constant, no, you can take 1 by 5 into e to the power of 2x minus e to the power of 3x. Hence, by differentiating this we get what? Dy by dx. Dy by dx is constant, we have to keep constant as it is. Differentiation of function e to the power of 2x. Differentiation of e to the power of function is 2x into d by dx of 2x minus again e to the power of function into d by dx of function. This will become what? 1 by 5 into e to the power of 3x into differentiation of 2x 2 into 1 minus e to the power of 3x into differentiation of 3x is 3 into 1. Finally, we have 1 by 5 into 2 into e to the power of 3x minus 3 into e to the power of this is 2 3x. It is the dy by dx. Again we have to find d square y by dx square. Dy by dx is differentiated once again. Again differentiate with respect to x. What we will get? We get d square y by dx square, that is d square y divided by dx square is equal to, keep 1 by 5 as it is, keep 1 by 5 as it is, 2 into differentiation of e to the power of function, e to the power of function into differentiation of 3x, that is sorry again this is 2 into differentiation of 2x is 2 into 1 minus 3 into e to the power of 3x, differentiation of e to the power of function is e to the power of function into differentiation of function, that is 3 into 1. Finally, d square y divided by dx square become 1 by 5 into 2 into 2 4 e to the power of 2x minus 3 into 3 this 3 9 into e to the power of 3x. Our question is what? D square y by dx square at x is equal to 0. Put x is equal to 0. Then d square y divided by dx square become 1 by 5 into 4 into e to the power of 2 into 0 is 0 minus 9 into e to the power of 0. As we know that anything to the power of 0 except 0 to the power of 0 are all equal to 1. Therefore, e to the power of 0 is equal to 1. According to that, if you substitute here 1 by 5 into 4 into 1 minus 9 into 1, which is equal to 1 by 5 into 4 minus 9, or 1 by 5 into minus 5, which is equal to minus 1. The answer is what? Minus 1 is d square y by dx square at x is equal to 0. This is an examination problem. I will take very simple example. If y is equal to log x, find d square y divided by dx square. Such problem may be asked for 2 marks questions. Y is equal to what? Log x. Differentiate this, dy by dx. Dy by dx is 1 by x. Again differentiate this, you will get d square y by dx square. This is 1 by x to the power of n, derivative is what? Minus n by x to the power of n plus 1, right. According to that, d square y by dx square is minus 1 by x to the power of 1 plus 1, that is minus 1 by x square. It is an answer. Sometime very simple question will be asked for 2 marks questions, that like this. You take another example, y is equal to if x is equal to 80 square and y is equal to what? Y is equal to 280. Find d square y by dx square. It is what? It is a parametric function. It is a parametric function. You take x. What is x? X is 80. X is equal to 80 square. Dx by dt, differentiate x with respect to t, we get a into 2t, that is 2at. You take y. Y is equal to what? 2at. Differentiate with respect to t. What we get? We get dy by dt. So, dy by dt is 2a into t. Therefore, dy by dx is equal to dy divided by dt divided by dx divided by dt. Here 2a is taken as it is, differentiation of t is 1, it is 2a. By substituting here dy by dt, dy by dt is 2a. This is what? 2a into t. 2a cancel, it is equal to 1 by t. So, dy by dt, dy by dt is what? It is 1 by t. Again differentiate this, again differentiate with respect to x, we get d square y by dx square. It is nothing but what? D by dx of 1 divided by t, d by dx of 1 divided by t. So, differentiation of 1 by t, we have to differentiate with respect to t, but here the t is the function is in t. You differentiate according to 1 by x square, it is minus 1 by t square into, because of the function is in t, we have to write dt by dx, dt by dx. Why we are writing dt by dx? Because the dy by dx is in t. When if you differentiate it again with respect to x, it will become 0, but we should not take it 0. Hence, we have to differentiate this with respect to t, and t derivative is taken dt by dx. Therefore, it will become what? Minus 1 divided by t square into dt by dx. Dt by dx is what? Dt by dx, we have to take reciprocal for it, reciprocal like this, 1 by minus 1 by t square into reciprocal dx divided by dt, 1 divided by dx by dt, dx by dt is 2at, hence it is minus 1 divided by 2 into a into t cube, minus 1 divided by 2 into a into t cube is the answer. You take another example, it is very important it is very important problem with respect to your exam. the question is, if y is equal to tan inverse x, y is equal to tan inverse x, prove that 1 plus x square into y2, 1 plus x square into y2 plus 2x1, 2x1 is equal to 0. So, in most of the question papers, this question will be there always. You take y, tan inverse x, y2 is what? Y2 is nothing but d square y by dx square, correct? Y1 is what? Dy by dx. So, y is equal to tan inverse x is there. If you differentiate this, we will get what? Y1. Y1 is dy by dx. I will take it as the derivative of tan inverse x, 1 by 1 plus x square. The answer is in the equation form, is it right? The answer is in equation form. That is why we have to take the derivative in equation form only by cross multiplying this to this side, 1 plus x square into y1 is equal to 1. If you differentiate this, you will get the answer directly. How to differentiate this? 1 plus x square into y1, it is of product rule, u into v. What is u? Using product rule, 1 plus x square into differentiation of y1, d by dx of y1 plus y1 into d by dx of 1 plus x square is equal to differentiation of 1 is 0. You take 1 plus x square into differentiation of y1, I should take it as y2, because y2 is what? D square y by dx square, plus y1 into differentiation of 1, 0, plus differentiation of x square is 2x is equal to 0. Hence, it is 1 plus x square into y2 plus 2x into y1 is equal to 0. It is the required result. Clear? You take y is equal to tan inverse x, differentiation of tan inverse x is what? 1 by 1 plus x square, you cross multiply it, you will get 1 plus x square into y1 is equal to 1. Hence, it is product of two function, again it is to be differentiated, you will get u into v, 1 plus x square into d by dx of y1 plus y1 into d by dx of 1 plus x square is equal to 0. Keep 1 plus x square as it is, differentiation of y1 is y2, keep y1 as it is, differentiation of 1 0 plus 2x, it will be 2 into x into y1, 1 plus x square into y2. This is answer. You take another example. What is that? The function is y is equal to sine of log x, y is equal to sine of log x. With this we have to prove that x square into y2 plus x y1 plus y is equal to 0. Y is equal to sine of log x. We have to prove that x square y2 plus x y1 plus y is equal to 0. You differentiate this, what we will get? Y1. Y1 is equal to differentiation of sine function, it is cos function into d by dx of function log x, cos of log x into differentiation of log x. The next step, it will become what? Cos of log x into differentiation of log x is 1 by x. We are we are getting an equation form. The answer is equation form. That is why you cross multiply x here, it will become x into y1 is equal to cos of log x. Again differentiate this, differentiate with respect to x. How to differentiate? We have to differentiate on both side. X y1 is equal to cos of log x. See the left hand side, it is product of two term, that is u into v. According to product rule, x into d by dx of y1 plus y1 into d by dx of x is equal to, right hand side is what? Cos log x, differentiation of cos minus sin function log x into d by dx of log x. So, differentiation of log x is what? 1 by x, that is x into d by dx of y1, it should be taken as y2 plus y1 into differentiation of x is 1, it is minus of sin of log x into differentiation of log x, which is equal to 1. Again you cross multiply this x towards left hand side, then it will become what? X into x y2 plus y1 is equal to minus sin log x. Sin log x is what? Y. You multiply with x, remove the bracket, x into x is what? X square y2 plus x y1. You take this to the left side, it will become plus y is equal to 0. This is the answer. X2 y, x square y2 plus x y1 plus y is equal to 0, right. You take another example, y is equal to a cos mx plus b sin mx. If y is equal to a cos mx plus b sin mx, show that y2 plus m square y is equal to 0. We have to prove that y2 plus m square y is equal to 0. So, what is function? Function is y is equal to a cos mx plus b sin mx. By differentiating you will get y1, a is constant, differentiation of cos mx is minus sin mx minus sin mx into differentiation of mx, it is function, cos of function, differentiation of cos mx is m into 1 plus b into differentiation of sin, that is cos mx into differentiation of mx is m into 1. So, minus a m sin mx plus b m into cos mx, it is dy by dx. Again it is further differentiated, further, differentiate again with respect to x. What we get? We get y2. y2 is equal to minus a m are constant. A m are constant. We have to keep it as it is. Differentiation of sin mx. Differentiation of sin is cos mx into differentiation of mx is m into 1 plus b m, they are the constant. We have to differentiate cos, that is minus sin mx into differentiation of mx is m into 1. Simplify it, that is equal to minus m into m square a cos mx minus m into m, this m square b into sin mx, this is m into m square. I will take minus m square common, you have a cos mx minus b sin mx. This will become what? Plus, because I have taken minus here. You take given function y is equal to a cos mx plus b sin x. That means, here the bracket is taken as y minus m square y, y2 plus m square y is equal to 0. This is known as the successive differentiation, or we have to prove the equation. You take another example, y is equal to m sin inverse x. You take y is equal to e to the power of m sin inverse x. What we have to do here? We have to take y is equal to e to the power of m sin inverse x. You differentiate that y1 dy by dx is what? E to the power of function is e to the power of function into d by dx of function, that is e to the power of m sin inverse x into d by dx of m sin inverse x. Keep m as it is, write the derivative of sin inverse. The derivative of sin is what? 1 by root of 1 minus x square. We have to keep it as it is. At this stage, we have to multiply with root of 1 minus x square. When you multiply with root of 1 minus x square, what happens? It will become root of 1 minus x square into y1 is equal to m e to the power of m sin inverse x. Further differentiate with respect to x on both sides. The left hand side is what? It is root of 1 minus x square into y1. It is product of two functions. Use product rule. Keep root of 1 minus x square as it is. Keep root of 1 minus x square as it is, and differentiate y1, it is y2 minus, because here I have taken plus, keep y1 as it is, differentiation of root of 1 minus x square, it is 1 by 2 root of 1 minus x square is differentiation of 1 minus x square. 1 is what? Differentiation of 1 is 0 minus differentiation of x square is 2x. At the right hand side, it will become what? M e to the power of function is e to the power of function into d by dx of function. What is function? M into sin inverse x. Kept m as it is, 1 by root of 1 minus x square. See the last part of second line. In the third line, what happens? Root of 1 minus x square y2 will become as it is, 0 minus 2x is what? Minus 2x, there minus of plus, that will become minus y1 into 2x by root 2 root of 1 minus x square. At the right hand side, the m into m, it is m square e to the power of m sin inverse x divided by root of 1 minus x square. Again you multiply with root of 1 minus x square, what happens? It will become 1 minus x square by 2, 2 get cancels there, x into y1 is equal to m square into y. Y is what? E to the power of m sin inverse x. That is the derivative of or the required equation. So it requires lot of space to write it on board. That's why I explained there only. Now the last type of derivation differentiation, that is hyperbolic and inverse hyperbolic functions. Hyperbolic and inverse hyperbolic function. So the expression like e to the power of x minus e to the power of minus x divided by 2 is called hyperbolic sine function. That is, we have to take it as sin hx, or it is called arc sin x, that is e to the power of x minus e to the power of minus x by 2. Similarly, we can write cos hx is equal to e to the power of x plus e to the power of minus x divided by 2. Then tan hx can be taken as what? Tan hx can be taken as sin hx divided by cos hx. Therefore, it will become e to the power of x minus e to the power of minus x by e to the power of x plus e to the power of minus x. Similarly, we can write cot hx is equal to e to the power of x plus e to the power of minus x by e to the power of x minus e to the power of minus x. Secant hx is equal to 2 by e to the power of x plus e to the power of minus x. Cosecant hx, it is 2 divided by e to the power of x minus e to the power of minus x, because it is 1 by sin hx. Then how to get the derivative of this type of function? So, as we know that for this inverse is what? Sin h inverse x, cos h inverse x, tan h inverse x, this is cot h inverse, they are all inverse trigonometric functions. Cot h inverse x, secant h inverse x, cosecant h inverse x, they are all said to be inverse hyperbolic functions, and they are the hyperbolic functions. We have to get the derivative of these functions. I will take one, and based on that I will write the others directly. Derivative of sin hx, d by dx of sin hx. As we know that what is sin hx? It is d by dx of sin hx is e power x minus e to the power of minus x divided by 2. Is it right? This is equal to, you take 1 by 2 outside, differentiate e power x minus differentiation of e power minus x is minus x into minus 1. Hence, it is equal to 1 by 2 into e to the power of x minus of minus plus e to the power of minus x, and I can take it as e to the power of x plus e to the power of x minus x divided by 2. It is always cos h x, that is derivative of sin h x is cos h x. Similarly, I can prove that d by dx of cos h x is equal to sin h x. Derivative of cos h x is sin h x. Derivative of tan h x is equal to secant h square x, Similarly, I can show the derivative of cot h x is always equal to minus cosecant h square x. D by dx of secant h x, it is minus secant h x into tan h x. D by dx of cosecant h x is equal to minus cosecant h x into cot h x. The derivative of sin h x, cos h x, cot tan h x and other things, they are all equivalent to our trigonometric functions, except one or two differences. What the difference we can notice here? In trigonometric functions, differentiation of cos x is equal to minus sin x, whereas differentiation of cos h x is equal to plus sin hx, that is one point we have to remember. And differentiation of secant x is what? Differentiation of secant x is secant x into tan x, but in hyperbolic function derivative of secant hx is equal to minus secant hx into cot hx. Only this sign will come in when compared to the trigonometric function, whereas here the sign goes. This is the derivative of hyperbolic functions. Similarly, you just see the slide, I will show the derivative of inverse trigonometric functions. Derivative of inverse trigonometric functions, differentiation of sin h inverse x, derivative of sin h inverse x is 1 by root of 1 plus x square. You see the slide, I have mentioned the derivative of hyperbolic function and inverse hyperbolic function. Differentiation of sin h inverse x is 1 by root of 1 plus x square. Differentiation of cos h inverse x is equal to 1 by root of x square minus 1. Differentiation of tan h inverse x is equal to 1 by 1 minus x square, where x square is less than 1. dy dx of cot h inverse x is equal to minus 1 by x square minus 1, x square greater than 1. Secant h inverse x is minus 1 by x into root of 1 minus x square if x square is greater than less than 1, and derivative of cosecant h inverse x is equal to minus 1 divided by x into root of x square plus 1. Here we do not have the condition. These are the derivatives of hyperbolic and inverse hyperbolic functions. All the rules of differentiation is applicable here, and all the types of differentiation, that is successive differentiation, chain rule, parametric differentiation, and implicit functions, implicit derivative, logarithmic derivation, everything will apply here. I will show one or two examples. You take y is equal to sin h inverse x plus 2 cos x minus 3 tan hx. Sometime the function may be, hyperbolic function may be included along with trigonometric and algebraic functions. By differentiation it will become what? Differentiation of sin h inverse x plus differentiation of cos x, differentiation of minus 3 tan hx. It is sum or difference rule. You take derivative, dy by dx is equal to sin h inverse hyperbolic function. Differentiation of sin h inverse x is what? Just I shown it, it is 1 by root of 1 plus x square. Is it clear? Differentiation of sin h inverse x is 1 by root of 1 plus x square plus 2 into differentiation of cos x, it is minus sin x. It is not hyperbolic, it is trigonometric function, minus 3 into differentiation of tan hx. Differentiation of tan hx is equal to secant h square x. So, it is 1 divided by root of 1 plus x square minus 2 into sin x minus 3 secant h square x. We are used the sum or difference rule. You take another example, y is equal to x square into cos h x. Basically, I used to take as product of two functions, then differentiation of this is what? We have to use product rule, dy divided by dx is equal to, keep x square as it is, differentiate cos h inverse x, cos h x plus write cos h x as it is, differentiation of x square, I have used according to the product rule. Then wherever we have d by dx, that is differentiated. For x square we have to write as it is. Differentiation of cos h inverse cos hx is what? Sin hx plus cos hx into differentiation of x square is 2x. See, we have to follow all the rules, sum rule, product rule, quotient rule, and the differentiation of implicit function, chain rule, everything we have to include for hyperbolic functions. Then you take another example, y is equal to sin h square 2x. Find dy by dx. Find dy by dx. What is given function here? It is sin h y is equal to sin of h 2x whole square. How it is to be considered? It is to be considered as function to the power of n. We have to use chain rule. Differentiate this, dy by dx is equal to differentiation of this function to the power of n into function to the power of n minus 1 into d by dx of function sin h 2x. Then differentiation of sin h 2x, other things we have to keep it as it is, hence it will become 2 into differentiation of, this is 2 minus 1 is 1, differentiation of sin h, it is again function of sin h function differentiation is cos h function into d by dx of 2x into d by dx of 2x. Finally, I can write 2 sin h 2x into cos h 2x into differentiation of 2x is 2 into 1. Otherwise, I can take 2 into 2 as 4 into sin h 2x into cos h 2x. This is the derivative of y is equal to sin h square 2x. You take the next example, y is equal to, if y is equal to 3 sin hx plus 2 cos hx, find d square y by dx square. Y is equal to 3 sin hx plus 2 cos hx, find d square y divided by dx square. Here we have to go according to successive differentiation. Is it right? Differentiate for the given x, the given y with respect to x, keep 3 as it is, differentiation of sin hx is cos hx plus 2 into differentiation of cos hx is sin hx. Again differentiate with respect to x. What we will get? We get d square y divided by dx square, that is equal to 3 differentiation of cos sin hx plus 2 into differentiation of sin hx is cos hx. Again this is taken as y. Therefore, d square y divided by dx square is equal to y. Successive differentiation. Like that, you can have any type of derivative with the hyperbolic and inverse hyperbolic functions. if y is equal to tan h inverse x whole square, find dy by dx. This is what y is equal to tan h inverse x whole to the power of 2. If you find dy by dx, it is of what? Function to the power of n into function. What is function? Tan h inverse x to the power of 2 minus 1 into d by dx of tan h inverse x. This is 2 tan h inverse x into differentiation of tan h inverse x. The derivative of tan h inverse x is what? It is 1 by 1 minus x square. It is 1 by 1 minus x square, which is equal to 2 tan h inverse x divided by 1 minus x square. This is the differentiation of function y is equal to sin h inverse x whole to the power of 2. So far we discussed a few problems on hyperbolic and inverse hyperbolic functions. So, you can work out few other problems based on this hyperbolic and inverse hyperbolic function. So, till now we have discussed all the types of differentiation from first principle to the last, that is hyperbolic, right. So, with this I suggest you that differentiation is very simple, but it is like procedure. We have to follow the procedure. It is similar to suppose a problem is given on product rule, we have to use product rule, it is common, where the function will changes. That means we have to follow the procedure. When compared to M1, this is very simple. You follow the basic concepts, ideas, then you can able to understand the differentiation. With this you can also able to understood the integration that will be taken in the next classes. So, in the next series of classes you will have the applications of differentiation, integration and differential equations. Some of my colleague will take other those topics. So, my topic is limits and differentiation. So, I have given the maximum knowledge about limits and differentiation. If you come across any question, any query in this topic, you can call me at any time to this number. My number is 944 88 322 944 88 322 79. You can call me at any time regarding any doubt in mathematics, not only in my topic, that is limits and differentiation. You can ask me any topic in mathematics that related to your syllabus, and also you can call for clarification of any doubts in science also. So, with this I conclude my this session. I wish you all the best. I hope you will follow my instructions. Definitely you can score good marks. With this I will conclude my session. Thank you very much.